Today we're talking about inequalities, compound inequalities. I've got a few terms that we're going to be talking about. Make sure you make a note of these. They'll come up slowly as we work through the lesson, so do make sure that you've got those in your notes. They'll be important. This word in particular is going to play into future lessons, so it's going to be very important that we get those understood and written down. Last week we talked about inequalities. We talked about how x could be less than or greater than another number and how that has to be illustrated using a number line or maybe using interval notation. And we're going to explore that a little bit more today and maybe tomorrow, we'll see. So be taking notes, be watching as we walk through this. We need to talk about this idea of compound. So first, let's look at this situation here. When we've got just the simple x greater than 3 inequality, of course, we learned last week that this means that all of the numbers that are larger than 3 satisfy this inequality, right? Numbers like 4, 10, 23, 127, right? These are all numbers that would satisfy this inequality. Numbers that wouldn't satisfy the inequality are like -2 or 1 or 0, right? These don't work. So that means that there's a specific set of numbers that do satisfy this thing and a certain set of numbers that don't. I can pick numbers and put them over here on the right and say this goes in, this works, and take some numbers, put them in over here on the left and say these don't work, these aren't a part of this inequality. The things that fit, the things that work, we call these the domain. These are all numbers that satisfy our rule. Okay, and in this case our rule is x greater than 3, and we've talked about how to illustrate this. We could use the interval notation, right? Interval notation might look like 3 parentheses infinity over here, right? That's one way we've used to illustrate this. Or we might use the number line. We might go straight line, and then we'll put some tick marks. We'll say 3 is here, 2 and 1, and 4, 5, and 6. And we'd say, okay, we can't include 3 because it's not x greater than or equal to 3. It's just x greater than 3, everything above 3. So we put an open circle here, and we draw a line going to the right. And we indicate with an arrow that it goes forever. Every single number going that direction is going to satisfy this inequality. So the domain for this rule is every number bigger than 3 on the number line. We could illustrate it using both of these formats. So that would be our domain. Domain and interval notation are often very, very connected, and you'll see that as I dive into the next example. Here's our next example. I've got 2 inequalities up here. First one is -x minus 3 less than or equal to -2. Well, let's solve this. Let's go ahead and walk this through. We'll start by adding 3, right? Adding 3 on both sides, that cancels. -x less than or equal to -2 plus 3. Let's make this a positive 1. Since 3 is bigger, it takes the positive sign. And then we have to multiply both sides by -1 to cancel out this negative over here. So -1 multiplied on both sides, and x is greater than or equal to -1. Remember, when I'm multiplying or dividing by a negative value, the direction on this symbol has to change. It has to shift. So instead of being x, -x less than or equal to +1, it's x greater than or equal to -1. So watch out for that. That'll be a tricky thing. But that's our solution. If I were to sketch this on a number line, I would probably do something like this. Let me grab my black and sketch that number line here. Okay. And let's give it good wide margin here. And we'll say negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. And if I were to sketch this, x greater than or equal to negative 1 means that I put a solid marker here, right? A closed circle. And then I put a line going in this direction saying that it includes everything to the right. But I've got a second inequality over here, this x minus 2 less than 1. Let's go ahead and solve that one as well. So pretty straightforward. We add 2 on both sides. X less than 3. And if I were to do the same thing, if I were to sketch this, this now would look something like this. Open circle on 3, and a blue line extending to the left. Now here's the kicker. Today's lesson is on conjunctions. Conjunctions are an inequality statement where two separate statements are made in the context of our variable x. So we made one statement, and then we made a second statement, and now we're going to connect them with the word and. The word and. This is a conjunction. If you're familiar with the English language, the conjunction and usually connects two things together. So a man and woman, or a dog and cat, right? The two things together make a group. And that's what we're saying with this conjunction here. This conjunction is saying that I now have a rule that says that x has got to include a number that satisfies both of the rules, the one on the left and the one on the right. So when we look at our graph is going to say with the red, every number larger than negative 1, and with the blue, every number smaller than positive 3. But in order to satisfy both things at the same time, in order to satisfy a conjunction, we are actually only going to include these numbers here. The numbers between negative 1 and positive 3. We'll use that closed circle for the negative 1 because that satisfies this, and we'll use an open circle over here to satisfy this. If I were to express this using interval notation, which is a good thing, right? The thing we want to be able to do, we would say negative 1, comma 3, and because negative 1 has a closed circle, that gets a bracket, and 3 gets a parentheses. There is no infinity this time, because we're not going forever. 3 puts an upper cap on what our x can be, on our domain. Negative 1 puts a lower cap, an inclusive one, but a lower cap. So we're not allowed to go past negative 1 on the left, we're not allowed to go above 3 on the right. So our interval notation and our diagram both show what this conjunction implies for us. Now, sometimes you'll see conjunctions written with the word and in the middle. Sometimes you'll see conjunctions written with as if they are one statement, like this. And the way we deal with this is we will literally segment our statement into two inequalities, just like we did in the last problem. We might say negative 2 less than x minus 2, and then we might say x minus 2 less than or equal to 4. And then we solve, right? We just do the thing we know to do to solve our inequality. In the purple, I would add 2 and add 2. Cancels there. And actually, cancels here too, doesn't it? That becomes 0 less than x. And in the blue, I'll add 2 and I'll add 2. And x becomes less than or equal to 6. And I've got to now create a diagram and interval notation that satisfies both of these things. Well, the interval notation is not too hard, right? It's going to be 0 and 6. Those are the two numbers written out for us. And because this doesn't have the equals, it gets parentheses. And because this does have the equals, it gets a bracket. Now we'll just sketch the number line real quick. And we'll say that that's 6, 5, 4, 3, 2, 1, 0, 7, 8. Could have done that a little better, but it's fine. And we'll sketch it in red. Okay, once again, 0 is our lower boundary. Everything that x is has got to be bigger than 0, right? 1 can go here, 2 can go here, 3 can go here. These are numbers that satisfy the inequality. So that means 0 gets our open circle, and 6 is our upper boundary. X has got to be smaller than 6. So 5, 4, and 3, those satisfy. So we'll put a closed circle here, and then we'll sketch a line connecting them. And that, my friends, is how you do conjunctions. So, if you have any questions, make sure you let me know. Let's talk about disjunctions really quick. In English, a conjunction is any word that will connect like two other ideas together. They might connect a subject and a subject, or they might connect a verb and a verb, or they might connect like a whole sentence to another sentence, right? Those are things that conjunctions do. In mathematics, conjunctions connect domains, right? They restrict it so that we have to stay within a very strict set of rules. And a disjunction is going to connect domains too, but it's going to actually open things up a little bit more. It's not going to be so exclusive, so restrictive. And you'll see what I mean in a second. All right, so let's look at this. We've got negative x greater than or equal to 3. And this is actually pretty simple one-step solution. We just multiply both sides by that negative 1, right? And that becomes x less than or equal to negative 3. Okay, we change that direction because we're multiplying by a negative number. Okay, and we do the same thing over here. If we've got a negative 1x minus, or less than negative 1, excuse me, we multiply both sides by negative 1, multiply both sides by that negative 1, we get x greater than 1. And then, because this is a disjunction, now that we've got these things listed out, I'm going to throw in, and I probably should have had this to the start, but I'm going to throw in this word, or. This is what makes this a disjunction. And this is how it works out. If I were to sketch x less than or equal to negative 1 on a number line, which is what I'm going to do now, right? Let's just toss in our little tick marks here. We'll put 0 dead center. Say 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Okay, something like this. X less than or equal to negative 3 means that I'm going to put a closed circle on negative 3, and then I'm going to illustrate everything that would satisfy x less than or equal to negative 3. So we're going to go to the left, everything that's in this direction. Okay? That makes sense, right? That satisfies this thing. Then we're also going to illustrate everything that satisfies this, x greater than 1. So there's an open circle there, right? There is no equal to, so we've got to put an open circle on the 1. And then, because we're looking for stuff greater than 1, we're going to go in this direction to the right. And actually, I'm done now. I have included everything that satisfies this disjunction. Because this disjunction says, I am satisfied by everything that is both smaller than negative 3, or it could be greater than 1, right? Anything that hits into this thing, even if it doesn't fit in here, as long as it fits into this rule on the left, it satisfies the inequality. If it fits in the rule on the right, but doesn't fit into the rule on the left, it still satisfies the inequality. So 4 works, even though it doesn't fit here, it does fit here. 4 satisfies this, therefore it satisfies the entire statement. Same thing with -4. So it fits into this one. -4 satisfies this inequality, therefore it satisfies the entire statement. Or gives us more freedom to play, more freedom to include more numbers. Whereas the AND is going to restrict things, make it more limited. You might be wondering, well, what's the interval notation going to look like for this? Well, it'll look like this. Negative infinity all the way to -3, bracket, and we have to include 1 to infinity. And we might say domain equals to illustrate that this is the domain for our x. Okay. So the interval notation for x for this particular inequality set is actually going to use 2 separate parentheses sets. This one illustrating the inequality on the left, this one illustrating the inequality on the right. Okay? Let's look at another one. Okay, this one's going to require a little bit more work, but not much. I'll switch to blue so we can kind of look at these individually. So we've got -x minus 2 greater than or equal to 0. Let's go ahead and add the 2. Add the 2 on both sides, that cancels. -x is greater than or equal to 2. And then, of course, we've got to multiply by -1, and when we multiply by a negative number, we get x less than or equal to -2. That gives us that one. We'll put our or, we'll carry that back down. And we'll finish with this guy. Pretty quick, easy situation, x greater than 3. Alright, so we've got x greater than 3. X less than or equal to -2, we can illustrate pretty easily. Let's sketch that real quick. Okay. That's probably... Hold on, I don't like that. I want my number line to be clearer. Bear with me. I'm sure this is just delightful to watch. Let's put -2, let's put -4, -3, -2, -1, 0, 1, 2, 3, 4. That'll work. Okay, so the stuff on the right, x greater than 3, open circle on 3. And because we want stuff greater than 3, we need to have a line carrying this direction, right? And then, because we were looking for x less than or equal to -2, put a closed circle on -2, and we'll draw a line going to the left, including every value smaller than -2. And that is how we deal with disjunctions. Let me know if you got any questions. I'm always ready to answer those and happy to help.